Okay, today we're going to start on the Learning Standard AA20, which is how we factor algebraic expressions completely. And for the most part, Chapter 11 in the AMSCO Integrated Algebra textbook is all about factoring expressions. And then, so this will take us a while because we're going to have to learn how to factor monomials and factor trinomials and binomials. There's no new vocabulary for today other than the ones that we've been working with before: monomial, binomial, trinomial. Okay, so let's take you back to 6th or 7th grade when you learned how to write numbers as prime or composite. So remember that a prime number has 1 and itself as a factor, so it has exactly 2 factors. Okay, so for instance, the number 2 has 2 and 1 in it as a factor. So remember, a factor is a number that goes into, the factors of 2 are the numbers that go into 2 evenly. So 2 goes into 2 1 times, 1 goes into 2 2 times, so there's exactly 2 factors of 2. So 2 is the only even prime number. The rest of the prime numbers are odd numbers, but not every odd number is a prime number. So 9, for instance, has 3 as a factor, as well as 1 and 9. Okay, 1, incidentally, is not a prime. 1 is neither composite nor prime because it only has 1 factor, which is itself. Okay, so it doesn't have exactly 2 factors like you need for a prime number. Okay, so 13 is a prime number. 30 is a composite number, so any number that's not prime is composite. And if you want to find all the factors, so we're not saying, there's usually 2 things that you're asked. Sometimes you're asked to find the factors, and sometimes you're asked to find the prime factors. So I'm just asking you to find the factors. So you might remember a strategy that you used when you were in elementary school called the factor rainbow. Oops, that's a rainbow. Not spelled very well. Anyhow, doesn't really matter. But factor rainbow, this will find all the factors. So you made a rainbow and you started with 1, and at the other end of the rainbow you put 30. Okay? And then you put, if you want, you don't have to connect them. You can if you want, but you would connect the ends of the rainbow to the other factor that multiplies to 30. So 2 and 15 are connected because 2 times 15 is 30. And then you'd have 3, and then the other end would have 10, and then you'd ask yourself, well, is 4 a factor, which it's not, and then 5 is, and then you get to 6. And as soon as the factors like 5 and 6 are right next to each other, they are consecutive integers, you know that your rainbow is done because you started at the lowest factor and the highest factor, and you worked your way inward. Okay, so some factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. 30 has a lot of factors. Okay, then we think about 97. Now remember, there's a few different rules for figuring out if this is divisible by any integer below 10. Okay, so if it's going to have factors, it's going to have factors below 10 because if you think about it, 97 is just below 100. And every number below 100 can be written because the square root of 100 is 10. So any number below 100 can be written as a factor of something below 10 and maybe another number. So like, for instance, 40. I can write that as 4 times 10 or 2 times 20. At least one of the factors would be below 10. Okay? Not both the factors, but if I'm going to find a factor for 97, I know that whatever you multiply it by, so let's say that we're looking for 2 numbers that multiply to 100, one of those numbers will be below 10. Doesn't mean that both of them will be, though sometimes that is the case. It means that at least one of them has to be below 10 because 97 is pretty close to 100, and the square root of 100 is 10. Or the principal square root of 100 is 10. Okay, so let me think about, so I'm looking at numbers between below 10, so it's not divisible by 2 because the 1's digit is not even. 3, the check for 3 is if all digits add up to 3. So 9 plus 7 is 16. Oh, sorry, if all digits add up to a number divisible by 3, to a multiple of 3, we'll say. Okay, 16 is not a multiple of 3, so 97 is not divisible by 3. If I check for 4, 4 is a strange one, and I actually can't remember it right now. I think it has to be with 4 you have to just check. And I know that 4 doesn't go into this evenly because it doesn't go into any number with 7 in the ones digit evenly. Okay, so 5, it doesn't go into 5 because the number in the ones digit is not 0 or 1. For 6, I have to check for 2 and 3. For 6 it'd have to be divisible by both 2 and 3. Since it's not divisible by either one, it's not divisible by 6. Another one to check is, let's see, 8. I think I'm just going to have to check it real quick. That goes into that once, so I get 17 as a remainder, so that's 8's not divisible by, or 97 is not divisible by 8. And then for 9, I check. 7, I also have to check. So let's see, that goes into it once. That's 7 and 27. 7 doesn't go into 27 evenly. So no, it's not divisible by 7. For 9, 9's a lot like 3. If I add the digits together, I'd get 16. If this is a multiple of 9, then the number originally was a divisor of 9. Or was a multiple of 9, rather. So none of those check. So since I check the numbers between 1 and 10 and none of them are factors of 97, we can say that 97 is a prime number. Okay. Okay, so what we're going to talk about today is factors of monomials. We did a couple of factors in the previous pages of just numbers like you've seen before. But now we're going to bring this into the world of algebra by talking about monomials. So we have this monomial here, 60 x to the 5th, y to the 4th. And I'm wondering what the other factor is if one of the factors is 12xy. So what would I have to multiply 12xy by in order to get 60x to the 5th, y to the 4th? Well, in order to get 60 as a coefficient, the coefficient of the factor that's missing would have to be 5. In order to get x to the 5th, I'd have to multiply that by x to the 4th. So x to the 1st times x to the 4th gets you x to the 5th. And similarly, if I were to get y to the 4th, I'd need this second factor to have y to the 3rd in it. Okay, so the answer is y to the 4th, 5x to the 4th, y to the 3rd. Okay, what would I need to multiply this by in order to result in this monomial? Okay, -3 times, another way of looking at it is 60 divided by -3 gets you the missing coefficient there. That gets you -20, so I know that this, let me put this in red right here, the other number would have to be -20, because -3 times -20 is positive 60. Now, we have an x to the 5th and an x to the 4th, so I'd have to multiply x to the 1st, because x to the 4th times x to the 1st is x to the 5th. Okay, and that's what I have in my product. Y to the 3rd times y would have to be y to the 4th. So the answer is 20xy, or -20xy is the answer there. Okay, so my last question is, what would I have to multiply 10x squared y squared by in order to get 60x to the 5th, y to the 4th? Well, I'd have to get 60 as a coefficient, so I need 6 here. I need to multiply by x to the 3rd, and the second one would be x to the 2nd power. So another way of looking at this is what happens when I take 60 x to the 5th, y to the 4th, and divide it by 10x squared y squared. Okay, that's another way of looking at multiplication. You think about it as the missing factor problem. or you can think of, when you're missing a factor, you can think of it as a division problem, rather. Okay, so 60 divided by 10 was 6. X to the 5th divided by x squared is x to the 3rd, and x to the 4th divided by x squared is x squared. So another way of figuring out the missing factor is taking the result, which is 60x to the 5th y to the 4th, and dividing it by the monomial. 60x to the 5th y to the 4th divided by negative 3x to the 4th y to the 3rd would get you what we just arrived at before. Okay? So when I have to find the greatest common factor between two numbers, so again, I'm going to work back with numbers and show you how it relates to algebra. I think about, there's a couple of different ways I can do it. I can list the factors of these numbers, so 20, just thinking about the rainbow, so 1 and 20, and then 2, that would connect with 10, and then 3 doesn't go into it, but 4 and 5 do. And since those are consecutive, I know that I've listed all the factors for 20. And then for 84, I have 1 and 84. I have 2 and, let's see, 42. Just 3, so 8 plus 4 is 12, so 3 must go into it because 12 is a multiple of 3. So that's 6, so 24, and that goes into it 8 times. So 3 and 24. Does 4 go into it? Yes, it does. 2, that would get you 8, and bring down the 4, 1. So 2 and 21. Oh, sorry, that's 4 and 21. 21 would go there. 5 doesn't go into 84. 6, it's divisible by 2 and 3, so 6 must also go into it. So 6 and 14. I should have made the, I should have made my line a little bit bigger, but more spread out. Okay, then 7. 7 doesn't go. Well, it might be go into it once. 7, 1, 4. So it goes into it 12. So we have 7 and 12. Does 8 go into it? It doesn't. And 9 doesn't go into it. So that's all the factors here. So for 84, 84 has actually lots of factors. So I'd have to write 1, 2, 3, 4, 6, 7, 12, 14, 21, 24, 42, and 84. Okay? So to get the greatest common factor, so greatest meaning the largest number, common meaning it's common to both of them. Okay? I just have to, I can look through the lists. So I can say, okay, starting with 20. 20 is not a factor of 84, so let me cross it out of that list. 10 is not a factor of 84. 5 is not a factor of 84, but 4 is. Okay, so that's one way of doing it. So the GCF, a lot of times people write it like this. They write the GCF, and they write it like an ordered pair. 20 and 84 is equal to 4. Okay. Now 35 is a little easier because the factors are just 3 and 7. Nope, just joking. It's 5 and 7. And 18, the other way to do this is, instead of listing all the factors, is just to use prime factorization. So 18, I can make a factor tree from 18. 18 has a factor tree of, okay, so if you're, the factor tree is different from the factor rainbow because you don't, with a factor rainbow, you're listing all the factors. With a factor tree, you are just listing, you're breaking down the numbers until they are prime factors. Okay, so for 18, the first thing I want to do is I want to think of two factors, so 9 and 2. Now, if the number is a prime, I can keep it as it is, but if it's not a prime, I break it down further. And if it's prime, I just bring it down so that all these branches, so these are all prime, so all of these numbers multiply to get 18. So it's basically breaking it down to its basic building blocks. So this is the second way of finding the greatest common factor, is to use the factor tree and break each number down into the factor, its prime factors. and then think of them and see if there's anything in common. So 35 has a 5 in it and 18 doesn't. 35 has a 7 in it and 18 doesn't. And likewise, 18 doesn't share any prime factors with 35, so the GCF between 35 and 18 is equal to 1. The greatest common factor is just 1. These are called relatively prime. So we would say that 35 and 18 are relatively prime. Oops, I added an extra R in there, to each other because their GCF is 1. Okay, so how do we find the greatest factors between two monomials? So now we're going to talk about the algebra. Now, the way that we do it is we think about the GCF between the coefficients first. So the GCF between 20 and 84, we said before that that was 4. We used the last page to develop that. Now, when we look at x squared and x to the 5th, we're going to think of the GCF as being, so remember, x squared is just x times x. X to the 5th is x times x times x times x times x. Okay, so they both share 2 x's as factors. So their GCF between x squared and x to the 5th is x squared. So the GCF between x squared and x to the 5th is considered the one with the smallest exponent. Okay, because they both share x squared as a factor. Now, x to the 5th has more x factors in it than x squared does, so we just say that their common factors are x squared. Likewise, y to the 8th times y squared. Okay, think of y to the 8th as having 8 y's in it and y squared as having 2 y's. Well, they're going to share those 2 y's right here. Y squared is going to have 6 more y's in it. So the GCF between y to the 8th and y squared is going to be y squared. Okay, so the GCF between these two monomials is 4x squared y squared. Okay. Now, let's see, the GCF between 8x and 8x squared. So the GCF between the coefficients is 8. Okay, now 8 to the 1st power has 1x and 8 squared has 1x. So they actually share an x. So the GCF between 8x and 8x squared is 8x. Okay, and that's because 8x squared is a multiple of 8x. It's 8x times x. Okay, so if I took 8x and I multiplied it by x, I'd have 8x squared. So 8x squared is a multiple of 8x. Okay, because there's something you can multiply by 8x in order to get 8x squared. Okay, the GCF between 10xy and 5y. So they both share a 5 as a factor. Now this term has an x and this term doesn't, so we can't say that x is common to both of them, but 5y is common to both of them. Okay, so the GCF between 10xy and 5y is 5y. Okay. Now between these two, 36 is, 25 is 5 times 5, and there's no other way to get 25. 5 times 5, there's no factors that are shared with 36. So the coefficient of the GCF between these monomials is 1. Okay. Now, the GCF between x and x squared is x. This term has a y and this one doesn't, so it doesn't share it. The GCF between z squared and z is z. Okay, so the GCF here is just xz. Okay, and that's all you had to learn for today. So this is the first step in learning how to factor polynomials.